If you're prepping for a pharmacy exam or setting up a lab run, staring at a wall of glassware and stirring machines can be overwhelming. Brute force memorizing all 7 USP dissolution types is a fast track to mixing up your setups or failing a practical. Success depends on applied physics. You are balancing how easily a machine operates against how accurately it mimics human physiology. To lock down the correct sequence, you just need one sentence: baskets, paddles, cylinders, cells, and discs, then holders. We can map that sequence onto this decision tree. Everything starts at the top, the drug's formulation. From there, we have 7 possible paths. Dropping that phrase along the bottom creates a permanent mental map for our options. We evaluate each machine by looking at its setup complexity and weighing that against its ability to force difficult drugs to dissolve. Understanding the engineering mechanisms behind each choice, instead of just memorizing names, eliminates the risk of choosing the wrong setup and ruining your lab test. Types 1 and 2 are the workhorses of the lab. They are cheap, easy to set up, and rely on basic hydrodynamics, using fluid movement to dissolve the sample. Type 1 is the basket apparatus. The engineering relies on a spinning mesh cage that controls how fluid moves on the drug. That cage traps buoyant capsules and tablets, keeping them submerged in the media for the entire duration of the test. For Type 1, the mechanism is the mesh cage, and the ideal match is any formulation that floats. However, if your formulation has gummy excipients, they will clog the tiny holes in that mesh. This blocks fluid flow and invalidates your test data. If your pill doesn't float, you move to Type 2, the paddle. Here, the engineering is a rotating blade that stirs standard liquid media inside the vessel. This provides a robust, low-cost baseline with very fast setup times, making it the standard choice for non-floating tablets. However, the paddle design is susceptible to coning, which can artificially lower your recorded dissolution rates. As the paddle spins, undissolved powder gets pushed into a dead zone at the bottom center of the beaker. It piles up into a cone, avoiding the shear force of the steering blade. While Types 1 and 2 are fast and cheap, their reliance on basic stirring means lab techs must constantly monitor the run for physical failures like clogging or coning. Complex formulations, like 24-hour extended-release pills or highly insoluble drugs, break the capabilities of standard paddles and baskets. This brings us to Type 3, the reciprocating cylinder. Instead of stirring, this machine operates by physically dipping the samples up and down. This dipping motion allows the machine to lift the sample out of one beaker and drop it into another, mimicking the pH shifts a pill experiences moving from the stomach to the intestine. You gain physiological accuracy, but the setup requires rows of fragile glassware, increasing the risk of breakage during rapid media swaps. For drugs that are exceptionally difficult to dissolve, you need Type 4, the flow-through cell. This animated cross-section illustrates how Type 4 achieves sink conditions. By pumping a limitless supply of fresh media over the drug and flushing away dissolved particles, the machine maintains the concentration gradient necessary to force the drug to dissolve. Achieving perfect sink conditions requires higher equipment costs and a steeper technical learning curve to operate the pumps and filters. Compared to a simple Type 1 basket, plumbing and priming a Type 4 flow-through run demands significantly more setup time. Types 3 and 4 solve difficult formulation challenges by mimicking human biology, but they require a larger lab budget and more operational effort. The final 3 apparatuses are niche setups built for delivery formats that look nothing like a standard pill. Type 5, the paddle over disc, modifies the Type 2 paddle by adding a stainless steel sandwich mesh at the bottom. Type 6, the rotating cylinder, takes the spinning mechanics of Type 1 and scales them up with a larger solid cylinder. These exist specifically for testing transdermal patches. Type 5 handles standard patches, while Type 6 accommodates those with a larger surface area. These specialized machines occupy valuable lab space for formulations a standard facility may rarely test. Type 7 is the reciprocating holder, which utilizes a very small-scale dipping motion. This setup is reserved for low-dose delivery systems, like implants, where you need extreme precision in small volumes to prevent sample loss. Types 5, 6, and 7 are specialized modifiers for when the physical shape of your drug is incompatible with standard submerged or flow-through methods. To tie these mechanisms together, choose your apparatus based on the path of least mechanical resistance. Our completed decision tree maps drug characteristics directly to the machines. Floaters go to type 1, standard tablets to type 2, extended release needs type 3, poorly soluble drugs require type 4, patches use 5 or 6, and low-dose implants land on type 7. For everyday efficiency, default to the type 2 paddle unless the pill floats. If it floats, use the type 1 basket. For complex formulations that resist dissolution, you must accept the higher setup time of types 3 or 4 to achieve accurate sync conditions. This flowchart matches our sequence: baskets, paddle, cylinders, cells and discs, then holders. Matching the physical properties of the drug perfectly to the engineering of the machine prevents ruined laprons. Mastery of USP dissolution comes from understanding the physical trade-offs between machine engineering and drug behavior to guarantee accurate, efficient